Hey, this is Mr. A, and today I want to go through this worksheet with you. I am going to model how to calculate acceleration for some really easy examples. So on this sheet here, you will see that it is a comparison of a SmartCar, a Toyota Venza, which I happen to own, and a Model S Tesla. So if you are into cars and you like to think about sports cars, or maybe you'd like to own a sports car in the future, and you think about which sports cars you would like to buy, inevitably you would compare one sports car to another sports car. And so you would compare the performance of those cars. And the performance might be how quickly the car accelerates, because that's really where you get that feeling of power of the vehicle and what it can do. And so you, if you are into cars and you're into comparing the performance of sports cars, you would know that a common method of comparing the cars is how quickly the car can accelerate from zero, from a stopped position, the car being at rest, to going a speed of 60 miles per hour, which is a common highway speed. So how quickly can the car accelerate from 0 to 60 is a common way that you compare sports cars. And so I thought this would be a good example because we're talking about acceleration. And I want you to be able to recognize acceleration graphically, but I also want you to be able to calculate acceleration. So we're going to look at the three cars, the Tesla, the Venza, and the SmartCar, and how quickly they go from 0 to 60 miles an hour. So this is a speed versus time graph that I've drawn on the board, and it is the same graph that's on the handout here. This is science class, so we use metric units. So speed is measured in meters per second. So we need our equivalent for 60 miles per hour, because that's the final speed that we're going to be going, our cars are going to be going to. We want that in terms of metric units, not miles per hour, but meters per second. So if you do the unit conversion, it turns out that it's 27 meters per second. Is where the top speed is that we're going to be going to. The cars are going to be starting at 0 meters per second or at rest, and we just want to see how long it takes them to get to this final speed. For a smart car, it takes 20 seconds, so indicated here in orange, a time of 20 seconds to go to that speed. Mr. A's Toyota Venza in green takes 7.5 seconds. So I mark a point here, and that is the green line. And then the Tesla goes from 0 to 60 in 2.5 seconds. So that is the red line here. Okay? Now, when we calculate things, and this is very important for you getting started in physics, and your ability to solve word problems depends on the strategy that you have. And if you don't have a strategy for solving word problems, then you're more than likely not going to be as successful as if you do have a strategy. So I'm going to refer to my guess strategy several times during our study of physical science and physics. And guess is an acronym for writing down your given information, determining what it is that you want to know, or what is your unknown, you, what equation do you have, and then substitute and solve. So, first of all, what is our given information? We are told that, let's work on the smart car first. So what I want you to do is I am going to do the smart car. Then we together are going to do Mr. A's Venza. And then for you you are going to do the calculation for the acceleration of the Tesla. So I do, we do, you do. And you're going to turn this in. I want to see your calculations for all three cars. You're going to tell me what the acceleration of the Tesla is. If you get that correct, then I'll know that you've worked these problems correctly. So for the SmartCar, we are told that the SmartCar goes from 0 to 27 meters per second in 20 seconds. So there are some things that we can write down in terms of the variables that we want to know. First, let me write down the equation, and then I think that will help. So our equation for acceleration, I'm going to use the symbol A, is equal to our final velocity minus our initial velocity divided by our final time minus our initial time. This really is, as you recall, our change in speed over our change in time. That's what acceleration is. I didn't write delta V in this case. I wrote it out in more detail, showing final velocity minus initial velocity and final time minus initial time. So let's see if we can define some of these. Our final velocity is always going to be 27 meters per second, because that's what the cars are doing. They're going from 0 to 27 meters per second. So that's our final speed. Our initial speed, when the cars, before the cars start moving, well, they're not moving yet, so their initial speed is 0. The final time is whatever it takes to get to 27 meters per second. So for our SmartCar, it's 20 seconds. Okay? And then our initial time, well, since this is a race, a drag race, if you will, the time starts always at 0. So our initial time is equal to 0. Okay? This is our given information. This is our equation. This is our unknown. This is what we're trying to find out. And then all we do is substitute and solve. So we substitute the value for VF here, this is 27. The value for VI, which is 0. The value for the final time, which is 20 seconds. And the value for the initial time is 0. Now notice there was a minus sign here, so it's 27 minus 0, minus sign is here, 20 minus 0. Now these are zeros, so we can just ignore those, right? So really acceleration is just 27 over 20, the change in speed over the change in time. And we can use a calculator for that, or you can ask Siri that. What is 27 divided by 20?
It's 1.35.
And the answer is 1.35. Okay? So we need to use our, we need 1.35, 1.35. What do you say? We need to write units here. Speed, of course, is in meters per second, and time is in seconds. So meters per second divided by seconds is meters per second squared. Okay? 1.35 meters per second squared. That is about what you accelerated when we were out on the patio doing the great race. So you can outrun a SmartCar, at least for a little while. And then the SmartCar will probably beat you in the long run, right? So this is the number. Always circle your answer. that you should have in this part of your worksheet. All right? So I did that one. Let's do the next one together, and then you're going to do the last one yourself. This time we are given that the final velocity, again, is equal to 27 meters per second. The initial velocity, of course, is 0. The final time, now then, for the Toyota Venza is equal to 7.5. And the initial time is equal to 0. All right? The unknown, what we're trying to find out, is the acceleration, and we have an equation for that. The equation is the change in speed over the change in time, right? Which we will write out in detail as the final speed minus the initial speed divided by the final time minus the initial time. Okay? And now you just substitute values into the equation. Okay? I want you to go ahead and do that. Again, we are working in the middle space in your graph for Mr. A's Toyota Venza. What is 27 divided by 7.5?
That would be 3.6.
So Mr. A's Toyota Venza accelerates at 3.6 meters per second squared. Okay? 3.6 is the acceleration. And for the SmartCar, it was what, 1.3?
It's 1.35.
Okay, let's round that up to 1.4. All right. So now I want you to do the calculation and tell me what the acceleration of the Tesla is.